This video will cover most of the beginning content for thermochemistry, such as distinguishing between heat and temp, between endo and exo, looking at some energy diagrams, and thinking about the sign convention for energy. So when we talk about thermochemistry, and specifically the energy we study in thermochemistry, the energy always comes in one of two forms. Right? It's potential energy or kinetic energy. And for thermochemistry, both potential and kinetic energy are based on motion. So kinetic energy is that random motion of molecules. Because they are in constant random motion, they generate heat energy, which is what thermochemistry studies. And then there's also that potential energy component where particles, based on their arrangement, have the potential to move. And that potential motion would also contribute to heat. Okay, so thermochemistry is a study of the heat energy, and heat energy is motion energy for particles. And in any closed system, there's a law that says, similar as conservation of mass, that matter can't be created or destroyed, it's just transferred. Same with energy. Energy is never created or destroyed, but it does change from one form to another, which is why it's sometimes hard to quantify or keep track of, because there's lots of different ways that energy it manifests itself. But that means the total energy is always the potential energy plus the kinetic energy of the whole system. Now, again, in thermochemistry, when we talk about that total energy, that's called heat. So the heat is both the potential and the kinetic energy in any given system. It's the total energy. We can kind of get an indication for heat by measuring temperature, because temperature is a measure of that average kinetic energy component, and it has a relationship with heat for sure, because heat has kinetic energy as part of it. But the main difference between temperature and heat is that temperature is that average kinetic energy, and it only has to do with the kinetic energy, where heat is a total, and it has potential as well as kinetic. So temperature, we're just going to look at the motion, but for heat, it depends on like how many particles are there, and their speeds, as well as their potential and their kinetic. So heat has more variables. The other thing is how we refer to it. Temperature in an equation is T, heat in an equation is Q. So again, the kind of the difference between the two, because that's one of your learning targets. Heat is a total amount of energy, while temperature is just a measure of that average kinetic energy, right? Heat is an actual energy measurement. We measure it in joules, where temperature is measured in Kelvin, right, and has a relationship with joules, but it is not an energy measurement. If you increase the heat, you're going to increase the motion, but you won't necessarily always be increasing the kinetic energy, because you might be dealing with the potential. So a change in heat will lead to a change in motion, or the change in potential motion, or changing temperature will be guaranteed to mess with kinetic energy. Now, you've heard of the terms endo and exothermic before, and we've even said this class that endothermic means energy in. But the big difference when you're talking about a thermochemical situation where we're looking at this heat energy is what in means, what it means to have energy in. So when we talk about putting energy in, if you were to hold an object that's putting energy in and saying it's endothermic, it would probably feel cold to your hand. We're used to associating the term cold with endothermic, energy in. And the reason is because the energy is going into the system from the surroundings, and your hand is in the surroundings. So in an endothermic situation, you're putting energy into the system, which means actually the system is increasing in total energy gained. But what you're feeling with the cold on the outside is the lack of energy that exists now in your hand. The energy is going into the object. So the object itself is gaining in energy, but you as the surroundings are feeling the lack of energy. So we can do the reverse for exothermic. When it's energy out, your hand in the surroundings is going to feel that energy being released from that object into the surroundings. So the surroundings are getting hotter. The energy out, the out is going into the surroundings. But the system itself is actually decreasing in energy. The system itself is getting cooler. So you feel the heat being released, but the system itself is getting cooler. So then we think about those energy changes, energy in versus energy out, as it relates to a chemical process or a physical process. These two sets of graphs represent a chemical change for the top part, going from reactant to product, and then the bottom represents a physical change. Anytime from start to finish you're decreasing in energy, that's going to be exothermic, energy out. right? Because exothermic means energy is released into the surroundings. Anytime from start to finish, you are getting more energy. That's going to be energy in an endothermic. So of all the graphs in front of you, the one on the left where reactants start higher than products, that's exothermic because from reaction to product, you decreased energy, which means you let it out. The other one on the right, where you put energy in to go from reactant to product, that's endothermic because you ended at a higher potential energy than where you began. When it comes to phase changes, then, as your temperature continues to increase, so going from A to B to C to D to E to F, so up, right? That's all energy in. You're putting energy in to increase both the motion as well as the potential of the substances. So melting and boiling are both endothermic, energy in. Going the opposite direction, then F to E, E to D, D to C, right? Both condensing and then solidifying, those are all exothermic processes because you're decreasing in energy over time and that energy is being released. So anytime you see a graph that represents an energy change, whether it's a phase change or a chemical change, if start to finish you increase in energy, that's endothermic. And if in start to finish you decrease in energy, that's exothermic. In general, how we talk about energy is that Q, as I've already mentioned. If the Q is negative, that's our way of saying energy out or energy released. You can't have a negative energy. That negative sign simply means direction. So I have released my energy. That's what the negative means. And that means it's exothermic, okay? Which means you are releasing it from the system, the thing that's reacting, into the surroundings, right? Your hand will feel hot. If it's a positive Q on the other hand, that means there's energy in from the surrounding to the system, in which case you're going to be gaining energy inside, and so that's endothermic. Those are all your beginning topics. Go ahead and do the form and have a nice night.